Tonight, we uncover the final threshold of the observable universe, where a single flicker of ancient light has revealed that we are not living in an infinite void, but inside a container that has just begun to show its walls. For 30 years, we told ourselves that the James Webb Space Telescope was a time machine. We believed that by peering into the infrared darkness, we would see our own dawn, the slow, graceful assembly of the first stars from a cooling fog of hydrogen. We expected to find the whispers of our ancestors, the quiet, humble beginnings of everything we have ever known. Instead, we found a scream. In a patch of sky catalogued as empty, the telescope's golden eye caught a glimpse of a galaxy that should not exist, a massive, luminous giant standing in the center of the nursery, chemically mature and structurally perfect, at a time when the universe was barely out of diapers. But the true horror isn't the galaxy itself, it's what the galaxy is sitting against. There is a pattern in the data, a geometrically clean, repeating signal that suggests the light from this impossible object isn't just traveling through space, it is being bent by a surface, a boundary. We built a machine to see the beginning of time, but it seems we have accidentally found the edge of the room. Picture a morning in late December 2021. Deep in the humid, oppressive heat of the jungle in French Guiana, a rocket sat on a launch pad, its nose cone holding the most expensive and fragile object ever conceived by the human mind. For the men and women who had spent 3 decades of their lives on this project, there was no Christmas joy that morning, only a paralyzing, leaden terror. Among them stood John Mather, a Nobel laureate who had been chasing the first light of the universe since the 1980s. He watched the Ariane 5 rise into the sky, knowing that between humanity and the secrets of the cosmos stood 344 single points of failure. 344 individual mechanical moments where a single stuck latch, a shredded cable, or a stubborn motor would transform $10 billion and 30 years of labor into the most expensive piece of debris in history. There was no shuttle to fly up and fix it. There would be no second chance. The telescope was heading for a gravitational sweet spot nearly 1 million miles away, a place called L2, where it would sit in a permanent, freezing silence, shielded from the glare of the Earth and the heat of the sun. To see the objects we are about to discuss, the telescope had to be colder than the vacuum between the stars. It needed to be sensitive enough to detect the thermal signature of a bumblebee at the distance of the moon. Its 18 hexagonal segments, coated in a layer of gold, just a few atoms thick, were designed to form a single, perfect reflector, a golden retina. We reconstructed this eye not just to see further, but to see differently. You see, the universe is expanding. As light travels across the vast, stretching fabric of space-time, its wavelength is pulled and elongated. Light that began its journey as a brilliant ultraviolet blue 13 billion years ago has been stretched so far that by the time it reaches us, it has slid off the visible spectrum entirely. It has become infrared. To our eyes, the early universe is a wall of blackness. To the golden retina, that blackness is a vibrant, crowded tapestry. When the first images were finally unveiled, the world saw a field of thousands of galaxies in a patch of sky, no bigger than a grain of sand held at arm's length. It was a triumph. But as the researchers began to dissect the light, the triumph turned into a crisis. They pointed the telescope at a tiny red hue in the constellation Fornax, an object they labeled JADES-GS-Z14-0. The numbers that came back were absurd. They ran the calculations again, certain they had found an artifact in the mirrors or a ghost in the software. But the signal held firm. This galaxy existed just 290 million years after the Big Bang. In the context of the universe's 13.8 billion-year history, This is the equivalent of the cosmos being barely 6 months old. According to every model of physics we have written since Einstein, galaxies are not supposed to form that quickly. They need time to gather gas, time to condense matter, and eons to ignite their first stars. The standard model of cosmology, a framework known as lambda CDM, had predicted that at this age we should only find small, chaotic clumps of baby stars. We expected to see the universe's first draft. Instead, we found a giant. JADES-GS-Z14-0 was 1,600 light-years across and blazing with the luminosity of several 100 million suns. It was an adolescent sitting in a nursery where only infants were allowed. It shouldn't have been there, yet it was staring back at us with a terrifying maturity. The unsettling implication began to settle in research offices around the world. Our timeline for the universe isn't just slightly off, it is fundamentally broken. We are missing a driver, a force, or a piece of geography that accelerated the assembly of reality itself. But the mystery deepened when they unraveled the galaxy's chemical makeup. Stefano Carniani and his team used the telescope's spectrograph to break the light into its component wavelengths, looking for the fingerprints of elements. They found oxygen. To you, oxygen is the breath of life. To an astronomer, oxygen is a ticking clock. The Big Bang did not produce oxygen, it produced only hydrogen, helium, and a trace of lithium. Every other element, every atom of the periodic table, had to be forged in the nuclear kilns of stars. To find detectable amounts of oxygen in a galaxy only 290 million years old is like finding a completed brick house just minutes after the kiln was built. It requires multiple generations of massive stars to be born, live their entire lives, and die in violent supernova explosions to seed the gas with heavy elements. Then, new stars must form from that enriched debris and repeat the process. All of this had to happen in a window of time that physics says is too short for even a single generation to finish. This creates a paradox that keeps physicists awake at 3 in the morning. If multiple generations of stars had already lived and died before the universe was 6 months old, then the cosmic dark ages, the period of darkness before the first stars, must have been far shorter than we believed. Or perhaps something was already there before the Big Bang itself. We are forced to consider that the universe did not start from a clean slate of hydrogen, but was perhaps seeded by the remains of something else. This was the first crack in the foundation. The monsters in the early universe were the first sign that the story we told ourselves about our origin was a comforting oversimplification. However, it was the golden retina's look at a supposedly empty calibration field that provided the most troubling insight of all. As the telescope was being used to reference a blank page of the cosmos, a region 11 billion light-years away with no known clusters or anomalies, it caught a signal that was not blank. It was a structured, repeating pattern. In cosmology, we are used to seeing the messy bending of light around galaxies, a phenomenon called gravitational lensing. But this signal was different. It was geometrically clean, too flat, and too extended to be caused by a cluster of matter. It looked like light hitting a surface. When theoretical physicists began to model the shape of this distortion, they realized it didn't match any known object in our universe. It didn't look like a galaxy, a black hole, or a filament of dark matter. It looked like a domain wall, a boundary between our region of space and another. We had been looking for the first light of our own universe, but the data suggests we might have found the fingerprint of a neighbor pressing inward. This is the vertigo of the new cosmology. The anomalous galaxies like JDs and its companions aren't just early structures, they are sitting right against this causal barrier. They may be the first structures to form not from the cooling of our own Big Bang, but inside the shockwave where our bubble universe collided with another. The unsettling implication is that we have mistaken the map for the territory. For a century, we believed we were charting the entire ocean, only to realize we have been looking at the ripples inside a single, enclosed tide pool. The troubling questions raised by these distant galaxies aren't just about how they formed, but about what they are shielding us from. If JADES-GS-Z14-0 is a marker on a wall, then our entire history, every star, every planet, and every human life is merely the ringing aftermath of a cosmic impact we are only now beginning to hear. We aren't looking at the dawn of time, we are looking at the edge of the container. And the more the golden retina stares into that darkness, the more it becomes clear that the container is not empty and it is not alone. We have spent our history looking up at the stars and wondering if we were alone in the void. We never stopped to ask if the void itself was alone. The discovery of these impossible galaxies has forced us to realize that the universe is not a self-contained story. It is a subset, a pocket of reality governed by local geography that we once mistook for universal law. As we peer further into the infrared, the structures we find continue to defy our simulations, because those simulations were built on the assumption that there was nothing outside, but the light from 13 billion years ago is carrying a different message. It is telling us that our universe is a collision in progress, and the monsters we see in the dark are the first evidence that the walls of our world are thinner than we ever dared to imagine. While the world celebrated the first shimmering portraits of the cosmic web, a small group of researchers retreated into the lead-heavy silence of their laboratories, staring at a ghost. In January of 2024, the members of the JADES team, the James Webb Advanced Deep Extragalactic Survey, were scanning a patch of sky in the constellation Fornax that had been meticulously catalogued for decades. To any previous instrument, this region was a void, a blank page in the story of creation. But through the golden retina of the Webb telescope, that void was bleeding. Hidden within a patch of darkness no larger than a grain of sand held at arm's length, they found it, a tiny, persistent red hue that would soon become infamous among cosmologists. There is a particular kind of terror that accompanies a discovery that is too perfect. As Kevin Heinlein, Stefano Carniani, and their international colleagues ran the initial measurements for the object they labeled JADES-GS-Z14-0, the numbers coming back were not just surprising, they were impossible. They ran the algorithms again, certain they were looking at a glitch in the sensors or a trick of gravitational lensing. But the red hue remained, a defiant flicker of ancient infrared light that had been traveling for 13.5 billion years to reach our mirrors. When the team finally committed to the spectroscopic analysis, the ultimate verdict in astronomy, the redshift came back at a staggering 14.32. To understand the weight of that number, you must look at the clock of the universe as if it were a human life spanning 80 years. At a redshift of 14.32, we are looking at a galaxy that existed when the cosmos was barely 6 months old. It is a moment sitting at the very edge of the cosmic dawn, a period only 290 million years after the Big Bang. Before this, we believed the universe at 6 months was still a cooling, featureless fog of neutral hydrogen, a dark age where the first stars were only just beginning to stir in their cradles. We expected to see whispers. We expected to see small, chaotic fragments of gas struggling to coalesce. Instead, through the infrared haze, we found a giant. JADES-GS-Z14-0 was not a baby. It was a sprawling, structured metropolis of stars, stretching over 1,600 light-years from edge to edge. To put that in perspective, if you could travel at the speed of light, crossing this single galaxy would take 16 centuries, longer than the entirety of recorded human history. It possessed a mass of several 100 million suns, blazing with a luminosity that rivaled galaxies billions of years its senior. The presence of such a mature structure in the infant universe is the cosmic equivalent of walking into a nursery and finding a fully grown oak tree where you expected to see an acorn planted just a week ago. This is where the vertigo begins. For nearly half a century, our understanding of the universe has been built on a framework known as lambda CDM, the standard model of cosmology. This model is the blueprint for everything we think we know. It tells a story of hierarchical structure formation, a slow, methodical process where small things merge to become large things over vast stretches of time. According to the standard model, building a galaxy as massive and organized as JADES-GS-Z14-0 should take at least 500 million years, perhaps a billion. The universe simply did not have enough time to grow this oak tree. There were no tools in our physics kit to explain how gravity could have pulled that much gas together, ignited that many stars, and organized them into a coherent, rotating disk in the blink of a cosmic eye. As you stare at that tiny red dot in the Fornax constellation, the implications begin to tear at the fabric of our certainty. If the standard model cannot account for the monster in the nursery, then the model is not just slightly off, it is missing a fundamental driver of reality. We are forced to consider that the early universe was not the simple, predictable soup we simulated in our supercomputers. Those simulations, which successfully predicted the distribution of galaxies in our local neighborhood, failed utterly when pushed back to the dawn of time. They predicted a sparse, dark landscape of tiny fragments. Webb found a crowded, luminous gallery of giants. What was the hidden engine that accelerated creation? Some researchers, like those who later found a companion galaxy at an even earlier redshift of 14.44, have taken to calling these objects MOM, the mirage or miracle galaxies. The name carries a desperate double meaning. If it is a mirage, then our instruments are lying to us, and the light we are seeing is a ghost of something closer and more mundane. But the spectroscopy has been checked and rechecked. The redshifts are real. This leaves us with the miracle. In the language of science, a miracle is simply a phenomenon for which we have no equation. Perhaps gravity behaved differently in those first few 100 million years, pulling matter together with a ferocity we have never measured in the modern age. Or perhaps, more disturbingly, the universe did not start from a clean slate of hydrogen and helium. These early giants are so mature, so chemically complex, that they suggest a prehistory, a memory of something that existed before the Big Bang itself. We are beginning to suspect that our universe is not a self-contained story that started at a single point, but a subset of a much larger, more violent process. The 6-month-old giant is the first crack in the container. It stands as a physical contradiction to our laws of time and assembly. If galaxies can appear fully formed where they shouldn't exist, we must face the unsettling possibility that our map of the cosmos is merely a local guide, and the real geography of the universe is governed by forces we have yet to name. The JADES team, staring at that red hue in the constellation Fornax, weren't just looking at the most distant galaxy ever seen, they were looking at the evidence that we have misunderstood the very nature of our beginning. We have been like sailors who believed they had mapped the entire world, only to find a continent that appeared out of the mist in a single afternoon. The question is no longer how this galaxy formed, but what kind of universe are we actually living in that allows it to exist? If the existence of a massive galaxy in the universe's first 6 months was a fracture in our understanding, then what Stefano Carniani found hidden in its light was the sound of the foundation finally giving way. Carniani, a researcher at the Scuola Normale Superiore in Pisa, was part of the international team tasked with dissecting the light of JADES-GS GS-Z14-0. They weren't just looking for a distance measurement anymore. They were looking for a chemical signature, a fingerprint that would tell them what this monster in the nursery was actually made of. They used the telescope's spectrograph, an instrument that acts as a cosmic prism, breaking the ancient, stretched infrared light into its component wavelengths. In the lead-heavy silence of his laboratory, Carniani watched as the data revealed a series of sharp, undeniable peaks. These were the emission lines of ionized oxygen. To a layman, oxygen is the breath of life, but to an astronomer, oxygen is a ticking clock. It is a brick of reality that takes time to manufacture, and in this 290-million-year-old void, those bricks existed before the kiln was supposedly hot enough to fire them. To understand why this discovery is so unsettling, we have to look at the ingredients of our own bodies. When the Big Bang occurred, it was a surprisingly simple event in terms of chemistry. It produced only hydrogen, helium, and a trace of lithium, the simplest, lightest elements in the periodic table. There was no carbon for our cells, no iron for our blood, and certainly no oxygen for our lungs. The early universe was a chemically barren fog of neutral hydrogen, a dark age where light could not travel far before being absorbed. For oxygen to exist, you need stars. You need massive, violent reactors capable of crushing hydrogen and helium together with such ferocity that they forge heavier elements in their nuclear cores. And most importantly, you need those stars to die. Oxygen only becomes available to the rest of the universe when a star exhausts its fuel and explodes as a supernova, scattering its forged remains across the void. This process is not instantaneous. It is a cycle of cosmic recycling that we believe took hundreds of millions, if not a billion years, to gain momentum. The first generation of stars, the so-called population 3 stars, had to be born from pure primordial gas. These were monsters, potentially hundreds of times heavier than our own sun, burning with an intensity and a heat that we can barely simulate today. They lived fast and they died young, but even their deaths were only the first step. Their debris had to cool, condense, and be pulled back together by gravity to form a second generation of stars. Only then, after multiple cycles of stellar birth and violent death, would the gas in a galaxy be enriched enough to show the kind of strong oxygen signal that Carniani identified. Yet here was JADES-GS-Z14-0, standing in a universe that was barely 2% of its current age, already chemically mature. It is the cosmic equivalent of walking into a construction site and finding a completed brick house just minutes after the first kiln was built. The bricks of life are already there, organized and abundant, at a time when our models say the clay should still be wet. This suggests that the cosmic dark ages, in the long period of darkness we thought preceded the first stars, might not have been empty at all. Instead, it may have been a crowded graveyard of hidden generations of stars that lived and died in a darkness we are only now beginning to realize was inhabited. The implications of this oxygen ghost tear at the very fabric of our certainty regarding the Big Bang. If multiple generations of stars had already lived and died before the universe was 300 million years old, then our timeline for the evolution of the cosmos is not just slightly off, it is fundamentally broken. We are forced to consider that star formation in the early universe was not a slow, methodical drip, but a geyser. Perhaps the first stars formed much earlier than we ever dared to guess, maybe within the first 50 million years. Or perhaps, as the law vault theories suggest, the universe did not start from a clean slate of hydrogen. We are beginning to suspect that these early giants were seeded by the remains of something else, a prehistory that existed before the Big Bang itself. As we use the golden retina to peer into this ancient void, the light of JADES-GS-Z14-0 becomes a haunting witness. It tells us that the early universe was far more active, far more dynamic, and far more violent than our simulations ever predicted. The oxygen Carniani found is a spectral ghost of a previous era. It is the chemical residue of ancestors we didn't know we had, stars that burned and died in a window of time that physics says is too short for even a single generation to finish its work. We are finding that the dawn of time wasn't a quiet sunrise. It was the middle of a story that had already been running at full speed. This creates a paradox that keeps physicists awake at 3 in the morning. If the universe was already producing complex elements like oxygen at redshift 14, then the first light we were looking for isn't the beginning at all. It is merely the first time we were able to see the results of a process that had been happening in the dark. We are realizing that our standard model was built on the assumption that we were seeing the whole picture, but James Webb has shown us that we were only looking at the ripples inside a single, enclosed tide pool. The troubling questions raised by this distant oxygen aren't just about how it formed, but about what kind of reality allows it to exist so soon. If JADAS-GS-Z14-0 is a marker of this accelerated evolution, it suggests that our universal laws might actually be local geography. Perhaps the physics of the very early universe was fundamentally different, driven by a hidden engine or influenced by a boundary effect from a neighboring reality. The oxygen is a symptom of a much deeper mystery. We are living in the ringing aftermath of a cosmic event that was far more complex than a simple explosion from a point. We are the children of a collision living inside a shockwave where two worlds met, and the monsters in the nursery are the first evidence that the walls of our container are thinner than we ever dared to imagine. Carniani's discovery of the oxygen ghost forces us to confront a vertigo-inducing reality. The universe has been a metropolis while we thought it was a wilderness. We have been like sailors who believed they had mapped the entire world, only to find a continent that appeared out of the mist in a single afternoon. Every atom of oxygen in your lungs today is a direct descendant of those hidden generations that died before the universe was even a year old. We are finding that our history is longer, darker, and far more crowded than we ever suspected. And as the golden retina continues to stare into that darkness, the question is no longer just how those stars formed, but what else was happening in that permanent silence before the light arrived. There is a specific kind of silence that exists only at 3 in the morning, a heavy, airless quiet that feels less like the absence of sound and more like the presence of a weight. It is the hour when the distractions of the day have evaporated, leaving only the raw, unvarnished questions that we spend our lives trying to outrun. For Alison Kirkpatrick, a professor of astronomy at the University of Kansas, this silence became a recurring character in her life in 2023. She had spent years mastering the mathematics of the cosmos, building a professional identity on the bedrock of the Standard Model, the map we have used to navigate the stars for a century. But as the data from the golden retina began to flood her screens, that bedrock started to liquefy. Kirkpatrick found herself lying awake in the dark, staring at the ceiling, wondering if every paper she had ever published, every lecture she had ever given, and every foundational truth she had ever believed was fundamentally wrong. This is the 3 a.m. vertigo, and it is not merely a personal crisis of confidence. It is the current state of modern cosmology. We are living through a moment where our most successful theories are being asked to account for objects that should not exist and expansion rates that refuse to align. The disorientation Kirkpatrick felt is the same disorientation now rippling through the entire scientific community as they realize that the map they've used to chart the heavens is not just slightly off, it is fundamentally flawed. The stars are not where we thought they were, and time itself is not moving in the way we have spent decades measuring it. To understand why a seasoned astronomer would question her entire life's work, you have to understand the Hubble tension, the most stubborn and destabilizing discrepancy in the history of science. For nearly a century, we have known the universe is expanding, and we have sought a single number to describe that rate, the Hubble constant. Get this number right, and you can calculate the age of the universe and the distance to every galaxy in the sky. But the universe has decided to give us two different answers. The first answer comes from looking backward, using the golden retina and the Planck satellite to map the cosmic microwave background, the ancient afterglow of the Big Bang. By projecting that early data forward, physicists arrive at an expansion rate of roughly 67 kilometers per second per megaparsec. The second answer comes from looking outward, using nearby pulsating stars and exploding supernovae to measure the expansion of the late universe directly. That method gives a result of roughly 73. A 6-unit gap might sound like a minor rounding error, but in the language of physics, it is a chasm. It is what cosmologists call a 5 sigma tension, a gold standard of certainty that means the probability of this disagreement being a fluke is roughly 1 in 3.5 million. It is the equivalent of building a bridge from both shores of a river and finding that when the two halves meet in the middle, they are off by a full foot. The engineering is perfect. The measurements are precise. Therefore, it is the blueprint itself that is broken. For a decade, we hoped the James Webb Space Telescope would resolve this tension, perhaps by revealing a subtle error in our local measurements. But in late 2024, when Nobel laureate Adam Rees used the golden retina to recheck the local expansion rate, the results were devastatingly consistent. The number held firm at 73. The measurement error was not the problem. We have simply misunderstood the universe. This realization is the source of the vertigo. If the early universe says one thing and the local universe says another, then the map connecting them, the very framework of how time and space evolve, is missing a fundamental piece of reality. But the Hubble tension was only the beginning of the crisis. In February of 2023, while Kirkpatrick and her colleagues were still grappling with the expansion data, a paper landed in the journal Nature that introduced the world to the universe breakers. A team led by Ivo Laber and Erica Nelson had pointed the golden retina at a tiny patch of the early universe and found 6 objects that should have been physically impossible. These were galaxies existing between 500 and 700 million years after the Big Bang, yet they possessed stellar masses of up to 100 billion suns. Under the standard model, the lambda CDM framework, the early universe was supposed to be a place of gradual, hierarchical assembly. Small clumps of gas were meant to slowly merge over billions of years to create the giants we see today. Finding a galaxy with 100 billion stars, just 600 million years after the beginning, is like walking into a prehistoric forest and finding a glass skyscraper standing among the ferns. It is the equivalent of finding a fully grown adult in a nursery where only infants are allowed. These universe breakers didn't just strain the model, they shattered the timeline of cosmic evolution. The unsettling implication of these giants is that the early universe was far more active, far more violent, and far more structured than we ever dared to simulate. If galaxies could appear fully formed at a time when only baby structures were permitted, then our understanding of gravity and time is incomplete. We are forced to confront the possibility that the cosmic dawn was not a quiet, gradual sunrise, but a sudden, explosive arrival, or perhaps even a rebirth from a previous reality. This is why the 3 a.m. silence feels so heavy for someone like Alison Kirkpatrick. It is the weight of realizing that we have mistaken the map for the territory. For a century, we believed we were charting an infinite ocean, only to find that we have been looking at the ripples inside a single, enclosed tide pool. If the universe breakers are real, and the spectroscopy confirms they are, then the universal laws we have relied on for decades are actually just local geography. The vertigo comes from the sense that the stars aren't where we thought because space is stretching at a rate we can't explain, and time is not moving as we measured because the early structures of the cosmos formed in a window that shouldn't have existed. We are seeing a maturing universe in its own infancy, a paradox that suggests we are missing a hidden engine or a fundamental driver of reality. When Kirkpatrick looks at the data, she isn't just seeing distant red dots, she is seeing the fractures in our container. The universe breakers and the Hubble tension are the first signs that the walls of our world are thinner than we imagined. We built the golden retina to see our birth, but it has shown us that our origin story is a comforting oversimplification. The troubling questions raised by these galaxies are not about how they formed, but about what they are shielding us from. As we sit in that 3 a.m. silence with the astronomers, we realize that the golden retina has done something far more profound than just breaking our models. It has peeled back the curtain of the observable void to show us that the universe is not a self-contained story. It is a subset of a much larger, more violent process. And as the ground continues to shift, we are finally coming to understand that the map we've used for 100 years wasn't a guide to the whole of existence. It was only a guide to the room we were trapped in. In the high-stakes world of observational astronomy, there is nothing more valuable than a blank page. To truly understand the light of the most distant galaxies, you must first understand the silence that surrounds them. You must find a place in the sky where nothing happens, a patch of the void so unremarkable that it can serve as a reference, a control field against which the rest of the universe can be measured. This was the task of a small team of analysts during the early operations of the James Webb Space Telescope. They were not looking for a discovery, they were conducting a ritual of precision. They pointed the golden retina at a region of space that had been catalogued for decades as boring, a quiet field with no known clusters, no recorded gravitational anomalies, and nothing worth a second look. It was supposed to be a calibration reference, a way to ensure that the telescope's mirrors and detectors were behaving exactly as the laws of physics intended. But when the data came back, it was wrong. The team ran their calibration checks once, then a second time, then a third. They tested the alignment of the 18 hexagonal mirrors, checked the temperature of the tennis court-sized sunshield, and eliminated every possible source of interference from inside the solar system and beyond. The signal did not go away. Tucked inside the infrared returns was a pattern that should not have been there, a structured, repeating signal with a geometry that had no match in the existing inventory of cosmic phenomena. In the world of the golden retina, boring is a precise condition. A quiet field has known properties that can be calculated in advance. But at a distance of roughly 11 billion light-years in a direction where the maps showed nothing but uniform emptiness, something was marking the light. The team realized they weren't looking at a ghost in the software or a glitch in the mirrors. They were looking at a geometric scandal. To understand why this signal stopped the team cold, we must look at how mass usually interacts with light. For a century, we have understood gravitational lensing, the way mass warps the fabric of space-time and bends the path of light passing near it. We have seen this messy bending around galaxy clusters, supermassive black holes, and the invisible halos of dark matter. Every gravitational lens we have ever mapped follows a specific template. The deflection is strongest at the center of mass and drops off in a predictable curve described by Einstein's general relativity. It is a curve that looks like a hill or a pit, a concentrated point of gravity tugging at the universe. But the distortion found in the calibration field was different. It was too smooth. It was too geometrically tidy. Most importantly, it was too flat. The mathematicians on the team found that the deflection didn't drop off in the way it should if it were coming from an object. It was spread across an extended angular area, consistent not with light curving around a sphere of matter, but with light bending along a surface. Imagine the difference between looking through a glass sphere and looking through a window pane. The sphere distorts the light into smears and arcs, the messy lensing we have come to expect from galaxies. But this signal looked like light hitting an extended planar boundary, a sheet oriented perpendicular to our line of sight. It was a phenomenon with no category. The analysts realized they had not found a new type of glass in the cosmic room. They had found evidence of the glass we are trapped inside. This forbidden geometry suggests that space-time 11 billion light-years away is not the uniform, empty stage we imagined. Instead, it appears to be divided by a structure that defies the standard model. If the lensing profile is truly flat and smooth, it indicates a domain wall, a physical surface in space where the laws of physics themselves may undergo a transition. We are used to thinking of the universe as an infinite ocean, but the golden retina has shown us that our ocean might have a shoreline. The troubling questions raised by galaxies like MOM-Z14 are no longer just about how they formed, but about what they are sitting against. These impossible galaxies may be the first structures to form inside the shock wave, where our universe is pressing against another. The vertigo of this discovery lies in the realization that we have mistaken the map for the territory. For 100 years, our equations assumed that the universe was self-contained, a single bubble of existence that began with a singularity and expanded into nothingness. But a flat, structured signal in an empty patch of sky suggests that our bubble has a neighbor. We are not living in an unbounded void, we are living inside a container that has just begun to show its walls. The signal is the fingerprint of something beyond the rim of our cosmos, pressing inward, distorting the light of our ancestors and leaving a mark on the structure of reality itself. The small team of analysts who first flagged the data did what scientists do when reality misbehaves. They documented the impossible and waited for a better explanation. But as they worked through every conventional candidate, galaxy clusters, dark matter filaments, instrument artifacts, they found that each one failed. The signal was well above the noise floor, it was real. And the more they stared at the smoothness of the distortion, the more they had to face the words they had been avoiding. This was not a localized mass. This was a surface in space where the curvature obeys different rules. It was a wall. As we sit in the silence of that calibration field, we realize that the James Webb Space Telescope has done something far more profound than just breaking our models of galaxy formation. It has revealed the forbidden geometry of our confinement. We built an eye to see the beginning of time, but we have accidentally found the edge of the room. We have been like prisoners who spent their lives studying the air in their cell, believing it was the whole of existence, only to finally notice the faint, repeating pattern of the wallpaper. The galaxies we see at the dawn of time aren't just early. They are markers on the glass. They are evidence that we are a subset of a larger, more violent process, a pocket of reality that was never meant to be alone. The implication is as ominous as it is exhilarating. If our universal laws are actually just local geography, then everything we think we know about the fate of the cosmos must be reconsidered. The expansion of our space, the behavior of our stars, and even the Hubble tension that keeps us awake at night may all be symptoms of this containment. We are standing at a boundary, looking through the golden retina at a permanent silence on the other side and realizing for the first time that we do not own the room. The troubling questions aren't about the stars anymore. They are about what the stars are shielding us from and what kind of universe exists beyond the forbidden geometry of the wall. For decades, the most radical idea in the history of science was a secret, whispered in the dimly lit corners of hotel bars and over the clinking of glasses at the end of conference dinners. Theoretical physicists, men and women who spent their days navigating the rigid, cold mathematics of the Standard Model, would lean in close to one another, speaking of things they dared not write down in their formal papers. They spoke of a universe that was not a single, infinite void, but rather a solitary bubble in a vast, frothing sea of other realities. To propose such a thing publicly was to invite the kind of institutional discomfort that could end a career. It was regarded as philosophy at best and science fiction at worst. Figures like André Linde and Alan Guth had followed the logic of their own equations into this corner, seduced by a mathematical elegance that suggested our Big Bang was not a unique event, but a common one, a single nucleation point in a process called eternal inflation. For 40 years, these ideas remained fringe, a haunting possibility that lived only in the minds of those who had realized that once inflation begins, the laws of quantum mechanics say it never truly stops. But then the golden retina opened its eye and the muttering stopped. To understand the weight of what we have found, we must return to the golden retina, the 18 hexagonal mirrors of the James Webb Space Telescope that have become the reconstructed eye of our species. We built this eye to look at the first light, believing we were simply mapping the early history of our own home. We did not realize that the golden retina was capable of seeing the wall of the room we have been trapped in for 13.8 billion years. The monster galaxies like JADES-GS-Z14-0 and the miracle of MOMZ14 are not just anomalies of time, they are markers of a universal edge. They are sitting right against a causal opaque barrier, a boundary where our ability to influence or even perceive reality comes to a sudden, absolute stop. In the quiet, technical returns from a calibration field that should have been empty, the telescope caught a signal that was too flat and too smooth to be a galaxy or a black hole. It looked like a surface. It looked like a domain wall. A domain wall is a concept that falls naturally out of Einstein's equations, though it was a door he never intended to open. It is a physical surface in space where a field transitions from one stable energy state to another, a boundary separating our region of space-time from a neighboring bubble. Imagine two soap bubbles pressing against each other. The thin film where they meet is the domain wall. In the context of the cosmos, this wall is a structure of immense tension and energy that curves space-time in a way that is fundamentally different from the messy gravity of a galaxy cluster. While a cluster bends light into smears and arcs, a domain wall acts like a window pane, bending light with a geometric tidiness that suggests a planar surface. This is the forbidden geometry that the golden retina has revealed. We are looking at a boundary that has been traveling toward us for 11 billion years, carrying the fingerprint of a neighbor pressing inward against our own reality. This discovery forces us to confront an implication that carries a heavy, airless vertigo. Our universal laws are actually just local geography. For a century, we assumed that the speed of light, the strength of gravity, and the mass of an electron were the irreducible rules of existence, held in place by the very nature of the universe itself. We believed that a hydrogen atom on the far side of the cosmos was identical to one in a laboratory on Earth because the laws were universal. But the domain wall hypothesis suggests that these regularities only hold true inside our own bubble. On the other side of that causal, opaque barrier, the inflaton field may have decayed into a different ground state, creating a universe where the strong nuclear force is weaker, where stars burn with a different fire, or where the very building blocks of matter refuse to cohere. Our entire scientific edifice, every equation we have ever written, has been based on a single sample, the local wallpaper of the cell we were born in. The troubling questions raised by galaxies like MOMZ-14 are not just about their age, but about their location. If these galaxies are sitting against the domain wall, their impossible maturity may not be a miracle of our own creation, but the result of the collision that started it all. In the framework of eternal inflation, the Big Bang was not a beginning from a single point. It was an impact. It was the ringing aftermath of our bubble universe colliding with another in the vast background of inflating space. The anomalous brightness and the mature chemical signatures of these early giants may be the first evidence of the shockwave generated by that cosmic meeting. They are the first structures to form not from the slow cooling of our own dawn, but from the violent energy of two worlds pressing together. The golden retina has shown us that we are the children of a cosmic accident, living inside the shockwave of a meeting we are only now beginning to recognize. This realization transforms the James Webb Space Telescope from a time machine into a threshold observer. We spent 30 years and $10 billion to build a tool that could see our ancestors, but we have accidentally built a tool that can see our container. The 3 a.m. silence that Alison Kirkpatrick felt was not just the fear of being wrong, it was the weight of realizing that the map she had mastered was only a guide to a single tide pool in an infinite ocean. If the laws of physics are local geography, then the fate of our cosmos is not an internal story. The expansion of our space and the Hubble tension that keeps physicists awake at night may be symptoms of this containment, pressures, and leaks from a reality that sits just beyond the glass. We are finding that our history is longer, darker, and far more crowded than we ever suspected because the void itself is not alone. The domain wall is a one-way information barrier, a permanent silence on the other side of a surface thinner than an atom. We can measure its distance, 11 billion light-years, and we can characterize its energy, but we can never see through it. It is the final threshold of the observable universe. As the golden retina continues to stare into that darkness, the objects it finds continue to defy our simulations because those simulations were built on the assumption of an empty exterior. We are discovering that our universal constants are merely the local settings of our bubble, and the monsters we see in the dark are the first evidence that the walls of our world are thinner than we ever dared to imagine. We have been like sailors who believed they had mapped the entire world, only to realize they were looking at the ripples inside a single, enclosed harbor. The muttering in the conference dinners has been replaced by a quiet, collective astonishment. The fringe ideas of eternal inflation and bubble collisions are no longer philosophical curiosities. They are the most viable explanations for the geometrically clean signal and the impossible giants at the dawn of time. We are standing at a boundary, looking through a golden eye at a reality we were never meant to access, realizing for the first time that we do not own the room. The troubling questions are no longer about how the stars formed, but about what the stars are shielding us from. We are observers inside a bubble, staring at the wallpaper, and finally noticing the repeating pattern that tells us the story of our beginning was always just a chapter in a much larger, more violent book. As we move deeper into the data, the image of the golden hexagons transforms. They are no longer just a mirror designed to catch ancient light. They are the door handle to a room we have just realized is part of a much larger house. We have spent our history looking up and wondering if we were alone in the void, but the golden retina has forced us to ask if the void itself is alone. The answer coming back from 11 billion light-years away is a geometric scandal. It is a wall, It is a boundary between worlds. And as we peer at that causal, opaque barrier, we are finally coming to understand that the map we have used for 100 years was never a guide to the whole of existence. It was only a guide to the local geography of our confinement. The universe is not a self-contained story. It is a collision in progress. In 1983, on an unremarkable afternoon in a world still divided by the Iron Curtain, a Soviet physicist named Andrei Linde was preparing to commit professional suicide. For years, the scientific community had been tethered to a version of the Big Bang that was tidy, singular, and safe. A moment of creation that began at a point of infinite density and expanded into a lonely, empty void. But Linde had followed the cold, rigid mathematics of the inflaton field to a conclusion that most of his colleagues found physically repugnant. He realized that if the process of inflation, the exponential ballooning of space, began once, the laws of quantum mechanics dictated that it could never truly stop. It was a self-perpetuating geyser of reality, spawning fresh pockets of space indefinitely. When Linde proposed this framework, initially calling it chaotic inflation, it was treated as a fringe curiosity, a mathematical ghost that lived only in the dimly lit corners of hotel bars and over the clinking of glasses at the end of conference dinners. For 40 years, the idea of eternal inflation was the secret the establishment didn't want to write down in their formal papers, until the golden retina opened its eye and found the ghost of a collision sitting in the very fabric of our sky. To understand why Linde's whispers have suddenly become the loudest signal in the room, we must return to the golden retina, the 18 hexagonal mirrors of the James Webb Space Telescope that have become the reconstructed eye of our species. We built this eye to catch the first light, believing we were simply mapping the childhood of our own home. We did not realize that by peering into the infrared darkness, we were actually looking at the ruins of an impact. The monster galaxies we have discussed, like JADES-GS-Z14-0, are more than just temporal anomalies. They are the first structures to form not from a quiet, cooling dawn, but from the violent energy of two worlds pressing together. In this new light, the Big Bang was never a beginning from a single point. It was a thud. It was the ringing aftermath of our bubble universe colliding with another in the vast, frothing background of inflating space. The evidence for this collision is not hidden in some distant equation. It is burned into the very map of the cosmos. For over 20 years, a shadow has sat in the southern sky in the direction of the constellation Eridanus that has caused a leaden discomfort among cosmologists. It is known as the cosmic microwave background cold spot. The microwave background is the ancient afterglow of the Big Bang, a map of the first light that filled the universe when it was just 380,000 years old. Normally, this map is a sea of uniform heat, broken only by tiny fluctuations, the seeds of future galaxies. But the cold spot is a scandal. It is a roughly circular region 5 degrees wide, enormous in cosmic terms, where the temperature drops 70 microkelvins below the average. For 2 decades, the mainstream attempted to dismiss this shadow as a supervoid, an empty region of space that chilled the light passing through it. But the calculations were never honest. When the math was run with precision, it was found that no supervoid in the standard model could be deep or large enough to produce that much cold. The cold spot remained, a circular anomaly sitting at the edge of our vision, behaving exactly like the bruise theoretical physicists had predicted in the 1990s. In the framework of eternal inflation, when two bubble universes grow toward each other, their boundaries eventually meet. At the margins of this meeting, the collision leaves a fingerprint, a circular region of altered temperature with a specific geometric profile. The cold spot in our sky is that fingerprint. It is the bruise where another universe hit ours at the moment of our birth. This realization carries a heavy, airless vertigo. We are not the children of a planned or ordered creation, but the residue of a cosmic accident. We are living inside the shock wave of a meeting between two realities. Think of the Big Bang not as a singular explosion, but as the moment the wall between two bubbles began to oscillate and ring like a struck bell. That ringing sent waves of energy through the space-time of our bubble, waves that were not uniform but carried a specific pattern, a spectrum of fluctuations imprinted on our universe by the collision dynamics. These waves provided the starting temperature, the starting density, and the specific seeds that would eventually become every star, every galaxy, and every human life. The troubling questions raised by galaxies like MOMZ14 and JADES-GS-Z14-0 are finally finding their answer in this impact. These impossible giants sit right against the causal opaque barrier we call the domain wall, the very surface where our bubble met its neighbor. Their maturity and their oxygen ghost, the chemical signatures of generations of stars that shouldn't have had time to exist, are the direct results of the collision's energy. These galaxies were forged in the shock wave. They didn't grow slowly from a featureless fog of hydrogen. They were flash-frozen into existence by the violent energy of two worlds pressing together. We built the golden retina to find our dawn, but it has shown us that our dawn was the middle of a story that had already been running at full speed in the void between universes. This transforms our entire understanding of universal law into something far more fragile. If we are living inside the residue of a collision, then the values we hold as absolute, the speed of light, the mass of an electron, the strength of gravity, are merely the local geography of the shock wave. On the other side of that circular bruise in the constellation Eridanus, the rules are different. The inflaton field decayed into a different ground state, creating a reality where atoms may not cohere, or where stars burn with a fire we cannot imagine. Our entire scientific history, every equation ever written, has been based on a single, local sample, the wallpaper of the room we were trapped in after the impact. The 3 a.m. vertigo that astronomers like Alison Kirkpatrick are feeling is the weight of this containment. For a century, we believed we were charting the entire ocean, only to realize we have been looking at the ripples inside a single, enclosed tide pool. The Hubble tension and the universe breakers are the first signs that the walls of our container are thinner than we ever dared to guess. The expansion of our space is not an internal mystery, it is the ringing that has not yet stopped. We are standing at a boundary, looking through a golden eye at a permanent silence on the other side, and realizing for the first time that we do not own the room. Andre Linde's dismissed papers from 1983 were not just mathematical exercises, they were the first attempt to describe our confinement. He saw that the Big Bang was not a beginning, but an impact, a thud in the dark that set our reality in motion. The cold spot is the ghost of that impact, still haunting the oldest map we possess. As the golden retina continues to stare at these monsters in the nursery, the image of the golden hexagons transforms. They are no longer a mirror designed to catch ancient light. They are a door handle to a room we have just realized is part of a much larger, more violent house. We have spent our history looking up and wondering if we were alone in the void, but the golden retina has forced us to ask if the void itself is alone. The answer, coming back from 11 billion light-years away, is a geometric scandal. It is a wall. It is evidence that our universe is not a self-contained story, but a collision in progress. We are the children of a cosmic accident, living in the echo of a meeting between two worlds, and the light from 13 billion years ago is finally telling us that the walls of our world are beginning to bleed. For over 25 years, the most profound mystery in physics has been buried under a name that sounds like a mathematical footnote, the cosmological constant. It began in 1917 inside the quiet, paper-strewn office of Albert Einstein. He was struggling with his own masterpiece, the equations of general relativity. To his dismay, the mathematics suggested a universe that was dynamic, a cosmos that had to either be expanding or contracting. But the 1917 version of reality was static, a permanent and unchanging gallery of stars. To save the stability of the heavens, Einstein performed a desperate act of mathematical surgery. He inserted a Greek letter, lambda, into his field equations. This was the cosmological constant, an invisible, repulsive energy embedded in empty space itself, designed to perfectly counteract the inward pull of gravity. When Edwin Hubble discovered the expansion of the universe in 1929, Einstein famously retracted the idea, labeling it his biggest blunder. He believed he had invented a ghost to solve a problem that didn't exist. But today, the golden retina has shown us that the ghost is real, and the blunder is actually the most terrifying discrepancy in the history of science. The trouble isn't that lambda exists, the trouble is its value. When modern quantum physicists attempt to calculate the energy of empty space, the irreducible minimum hum of the vacuum, they arrive at a number that is off by 120 orders of magnitude. Imagine a 1 followed by 120 zeros. In a field where we argue over decimal places, this is not a rounding error. It is the largest mismatch between theory and observation ever recorded. If the energy of the vacuum were as large as our best theories predict, the universe would have blown itself apart in the first trillionth of a second before a single atom could have cohere. Yet here we are. The observed value of this energy, which we now call dark energy, is bizarrely, suspiciously, almost perfectly small. We have been like people staring at a balanced scale, wondering what invisible hand is holding it in place, only to realize through the data of the James Webb Space Telescope that we are not looking at a balance at all. We are looking at a leak. In the world of high-precision cosmology, your results are only as good as the tools you use to measure them. Whether you are charting the expansion of the cosmos or securing your own digital footprint, the right framework makes all the difference. That is where our sponsor, NordVPN, enters the picture. Just as the golden retina shields its sensitive mirrors from the thermal noise of the sun, NordVPN creates a secure, encrypted bubble for your data, protecting your personal information from the external pressures of the open web. With over 6,000 servers in 111 countries, it ensures your connection is as stable as a L2 orbit, even when the local geography of your internet is compromised. Their threat protection feature blocks malware and trackers before they can even reach your device, acting as a causal barrier against malicious actors. If you want to protect your corner of the digital universe, go to nordvpn.com/goldenretina to get a massive discount on a 2-year plan, plus an extra 4 months for free. It's a risk-free way to ensure your data stays inside its own stable ground state. Now, back to the forbidden geometry. The leakage theory proposes a solution to Einstein's blunder that is far more unsettling than a simple mistake in arithmetic. If we accept the evidence from the forbidden geometry and the cosmic bruise, the idea that our universe is a bubble pressed against a neighbor, then the energy of our vacuum is not intrinsic to our space. One of the most radical implications of the domain wall is that the energy density at the boundary between two universes is not zero. The surface separating our bubble from another carries its own immense tension, its own heat, and its own energy. But that energy does not stay neatly contained on the wall. It leaks. Think of it like heat radiating from a warm surface into a freezing room. From our perspective, deep inside the interior of the bubble, this borrowed energy from the neighboring universe's wall would look exactly like dark energy, a diffuse, space-filling force with no local source, constant across the larger scales. This changes the entire narrative of why the universe is accelerating. We are not being pushed apart by a force born from our own Big Bang. We are being pulled by the energy of a world we can never visit. The observed value of dark energy is so small not because of a perfect cancellation of local physics, but because the boundary is 11 billion light-years away and the leakage rate is low. We have mistaken the heat of the wall for the nature of the room. The evidence for this external tug is quietly hiding in our maps of the cosmic web. When astronomers looked at the distribution of matter in the quadrant of the sky, where the golden retina found the forbidden geometry, they noticed a slight 2 sigma asymmetry in the distribution of voids. The enormous empty bubbles of space in that region were slightly larger than our simulations predicted, and the filaments of galaxies connecting them were slightly thinner. It was as if something in that specific corner of the sky was gently tugging matter outward toward the edge of our observable container. An external gravitational influence, a domain wall with its own non-zero energy density, would do exactly this. Over billions of years, the heat leaking from that wall has been sculpting the very structure of our reality, creating a subtle redistribution of matter that our internal physics alone cannot account for. This brings us to the most unsettling implication of the borrowed energy theory. If dark energy is actually inter-universal leakage, then the force tearing our universe apart is not an internal process of growth. It is a symptom of evaporation. We are like an ice cube sitting next to a furnace, feeling the surface of our reality begin to liquefy as the heat of another universe presses inward. We are being evaporated by the heat of a neighboring reality, a world with different constants and higher energy that is slowly but surely eroding the boundaries of our own. The 3 a.m. vertigo for physicists like Alison Kirkpatrick comes from realizing that we are not living in a self-contained story. The expansion of our space, the very movement of the stars, is borrowed from the outside. We are the children of a cosmic accident, trapped inside a shockwave, and the force we thought was the breath of the universe is actually the heat of its destruction. We are observers inside a bubble, staring at the wallpaper, and finally noticing that the wallpaper is starting to peel away. The troubling questions raised by those distant galaxies are not just about how they formed, they are a warning that the container is starting to bleed. We have spent our history looking up at the stars and wondering if we were alone in the void, never realizing that the void itself is being consumed by the energy of something far larger. In 2003, inside the quiet scholarly corridors of Oxford University, a philosopher named Nick Bostrom published a paper that would eventually become a recurring nightmare for the scientific establishment. He wasn't looking through a telescope or smashing particles in a collider. He was simply following the cold, relentless logic of probability to its most uncomfortable conclusion. Bostrom proposed that if any civilization, anywhere in the vastness of time, eventually develops the computational power to run high-fidelity simulations of their own ancestors, then the number of simulated realities would inevitably, astronomically, outnumber the single base reality that birthed them. Statistically speaking, if it is possible to simulate a universe, then the probability that we are the original version of ourselves is effectively zero. We would be, by definition, the ghosts in a machine we did not build. For 2 decades, this simulation argument was treated as a fascinating thought experiment, a bit of digital age theology that was impossible to prove and equally impossible to ignore. But then the golden retina opened its eye and found a physical structure at the edge of the observable void that looks exactly like a boundary in the code. To understand why a 20-year-old philosophical paper has suddenly collided with the cutting-edge physics of the James Webb Space Telescope, we must look at the nature of containment. Whether you are a programmer building a virtual world or a cosmic process nucleating a bubble universe in a frothing sea of eternal inflation, you are bound by the same fundamental constraint. Resources are not infinite. A computationally efficient simulation does not render the entire universe in perfect detail at every moment. That would be a waste of processing power. Instead, it renders only what is being actively observed, dropping the distant, unvisited corners of the cosmos to a lower resolution or skipping them altogether. If our universe is a constructed system, there must be a limit to the rendering, a place where the physics engine transitions between regions, a boundary where the internal logic of the world meets the edge of its container. This is the simulation/containment paradox. The more we use our technology to see further into the dark, the more we risk finding the artifacts of our own confinement. The forbidden geometry found by the golden retina in a supposedly empty calibration field sitting 11 billion light-years away is the first piece of physical evidence that this limit is real. As we have discussed, this signal is not a messy distortion caused by a galaxy or a black hole. It is a geometrically clean, planar surface, a domain wall. In the language of bubble nucleation and eternal inflation, a domain wall is the physical boundary where our bubble universe meets another. But in the language of the simulation argument, this same wall can be interpreted as a rendering artifact, a place where the code of our reality has reached its maximum angular extent and begins to show the grain of its own construction. Whether the container is made of mathematics or the energy of a transitioning inflaton field, the result for the observer is identical: containment. We have spent our history looking for the beginning of time, only to realize we have found the edge of the room. The vertigo of this discovery lies in the realization that we are a subset of a larger system that we can never fully access or communicate with. In the framework of eternal inflation, our Big Bang was merely a single nucleation point in a process that never truly stops. Beyond our domain wall lie an effectively infinite number of other bubbles, each with its own local geography of physical laws, different masses for the electron, different strengths for gravity, different values for the cosmological constant. We are a tiny, isolated pocket of stability inside a vast, violent background that we have no way to influence. If we are a simulation, the implication is even more unsettling. We are a subroutine running on a piece of hardware that exists in a reality so vastly more complex than our own that we lack the very concepts required to describe it. We are the inhabitants of a single tide pool, finally realizing that the tide pool is not the ocean, but a curated display inside a much larger house. This brings us to the most profound law vault realization of all. The domain wall is a one-way information barrier. It is a causal opaque surface. We can measure its distance, we can characterize the energy leaking from it as dark energy, and we can see how its presence has sculpted the large-scale structure of our cosmic web, but we can never see through it. Light from the neighboring universe or data from the base reality outside the simulation cannot cross that boundary and remain interpretable within our own physics. The crossing would be a transition between fundamentally different states of existence. As the golden retina continues to stare at the monster galaxies like JADES-GS-Z 14-0 sitting right against this barrier, we are forced to accept that these objects are not just early structures. They are markers on the glass. They are evidence of the collision that started our run, the ringing aftermath of our container's birth. Nick Bostrom's 2003 argument and the 2026 discovery of the domain wall are two maps of the same territory. Both describe an observer trapped inside a subset of reality. If the universe is a bubble, we are limited by the physics of our nucleation. If the universe is a simulation, we are limited by the parameters of the code. In both scenarios, our universal laws are exposed as merely local rules, the wallpaper of our specific cell. The troubling questions raised by the most distant galaxies aren't about how they formed, but about what they are shielding us from. We built a $10 billion eye to see the dawn of our history, but it seems we have accidentally caught a glimpse of the mechanism of our own confinement. We are staring at a permanent silence on the other side of the wall, realizing for the first time that we do not own the room. The containment paradox suggests that as our technology improves, the anomalies will not go away. They will sharpen. The Hubble tension and the universe breakers are the first signs that the internal logic of our world is beginning to fray at the edges as we push our observations to the very limits of what the system can render. We are finding that our origin story was a comforting oversimplification, a narrative designed to make sense of a reality that is actually just the ringing aftermath of a much larger, more violent event. We are the children of a cosmic accident, or perhaps the output of a mathematical process, living inside a shockwave where two worlds met. And as the golden retina continues to stare into that darkness, the light from 13 billion years ago is finally telling us that the walls of our world are thinner than we ever dared to imagine. We have always believed that knowledge was an unbounded frontier, that if we just looked further and thought harder, the entire scroll of the universe would eventually unroll before us. But the simulation containment paradox tells us there is a maximum knowledge limit. There is a boundary beyond which information cannot travel, a point where the subset cannot access the set. The domain wall at 11 billion light-years is that point. It is the final threshold of the observable universe, the edge of everything we have ever known. We are standing at that threshold now, looking through 18 hexagonal mirrors at a reality we were never meant to access, and finally coming to understand that the map we've used for 100 years wasn't a guide to the whole of existence. It was only a guide to the geography of our confinement. The universe is not a self-contained story. It is a collision in progress, and we are just starting to realize that the room is not alone. In the sterile, pressurized silence of a clean room at NASA's Goddard Space Flight Center, a new kind of witness is being assembled. It does not look like the golden retina that has spent the last few years dismantling our reality. It looks like a wide-angle lens designed to capture the entire story at once. This is the Nancy Grace Roman Space Telescope, a machine named for the woman who fought through institutional resistance to prove that the stars were worth a broad, systematic survey rather than just a series of narrow, deep stares. As technicians in white bunny suits double-check every bolt, circuit, and instrument alignment to ensure not even a single microscopic dust particle sneaks onto its optics, they are preparing what cosmologists have begun to call the verdict machine. While the James Webb Space Telescope looks at the early universe through a keyhole, a postage stamp-sized field of view that has already produced a dozen impossible anomalies, Roman is designed to see the entire poster. Its field of view is 100 times larger than Webb's, possessing the sensitivity to bring millions of distant galaxies into a state of statistical clarity. By the late 2020s, this observatory will sit 1 million miles from Earth, unfolding its deployable aperture cover to face the void and deliver the final word on whether our standard model is a foundation or merely a scaffold. The human story of the Nancy Grace Roman Telescope is one of calculated, leaden anticipation. Engineers have spent weeks in the Space Environment Simulator, a giant chamber that mimics the searing heat and freezing vacuum of the L2 orbit, knowing that once this machine launches, there can be no repairs, no patches, and no second chances. The stakes could not be higher. If the universe breakers and the oxygen ghosts found by the golden retina are merely statistical flukes, rare outliers caught by chance in Webb's narrow gaze, then Roman will reveal them as such, and the comfort of the standard model will be restored. But if those anomalies hold up at scale, if millions of galaxies across the same redshift ranges are found to be just as massive, just as bright, and just as chemically mature, then the statistics will be unambiguous. The verdict will not be a minor adjustment to a textbook. It will be the formal notification that we have misunderstood the very history of our universe. We are building a machine to confirm our own displacement, to prove that the map we have relied on for a century was never a guide to the whole of existence, but only a guide to the room we were trapped in. This brings us back to the golden retina, the 18 hexagonal mirrors that first caught the signal of our confinement. As we move deeper into the data provided by these golden reflectors, the image of the hexagons begins to transform in our collective consciousness. They are no longer just a mirror designed to catch ancient light. They are the door handle to a room we have just realized we do not own. We are standing at a threshold that is thinner than an atom, a boundary defined by the Planck length which separates our bubble of reality from whatever sits on the other side. In the framework of eternal inflation and bubble nucleation, this is the domain wall, a surface where the inflaton field transitions from our stable energy state into something else. It is a causal opaque barrier, a place where information from the exterior cannot cross in any form that our internal physics can interpret. We can measure its distance, 11 billion light-years away, and we can feel its heat leaking into our vacuum as dark energy, but we can never see through the glass. The troubling questions raised by galaxies like JADES-GS-Z14-0 and the miracle of MOMZ14 are not actually about how they formed. They are about what those galaxies and the boundary they sit against are shielding us from. If our universe is a subset, a tiny, isolated pocket of stability inside a vast, violent background of inflating space, or a rendering in a computationally finite simulation, then the boundary is the only thing keeping the exterior out. We have always believed that knowledge was an unbounded frontier, a scroll that would eventually unroll to show us the entire history of everything. But the discovery of the domain wall suggests a maximum knowledge limit. It tells us that there is a permanent silence on the other side, a reality governed by different constants and different rules that we were never meant to access. We are the inhabitants of a single tide pool, finally noticing the repeating pattern of the wallpaper that marks the edges of our harbour. The unsettling implication of this containment is that our universal laws are actually just local geography. The speed of light, the mass of an electron, and the strength of gravity are the rules of our cell, the local settings of our specific bubble. On the other side of that Planck-thin surface, the rules may be catastrophic for matter as we know it, or they may be so alien that we lack the very concepts required to describe them. The anomalies we see at the dawn of time, the giants that formed too fast, and the elements that appeared too soon, are markers on the glass. They are the ringing aftermath of the collision that started our story, the evidence that the Big Bang was not a beginning from nothing, but an impact between two worlds. We are the children of a cosmic accident, living inside the shockwave of a meeting we are only now beginning to recognize through our golden eye. As the Nancy Grace Roman Telescope prepares for its late 2020s journey, the distribution of opinion inside cosmology is facing a test that individual researchers cannot manage through interpretation alone. The numbers will either hold up at scale or they will not. There is no reading around a survey of hundreds of millions of galaxies. Roman is the next conversation the universe has to participate in directly. and the silence it encounters will be the ultimate answer. We have spent our history looking up at the stars and wondering if we were alone in the void, but the golden retina has forced us to ask if the void itself is alone. The answer coming back from 11 billion light-years away is a geometric scandal, a wall, a boundary, a limit. We are standing at the final threshold of the observable universe, looking into a permanent, freezing silence that sits just beyond the reach of our mirrors. The image of those 18 golden hexagons parked 1,000,000 miles away in the permanent dark is the most profound thing our species has ever constructed. They are the reconstructed retina of a god finally capable of seeing the room we have been trapped in for 13.8 billion years. But more than that, they are a reminder of our own humility. Nature operates according to its own rules, indifferent to the frameworks and models we construct to contain it. The troubling questions are an invitation to look deeper and think harder, to accept that the universe will always have more to teach us than our simulations could ever predict. We are observers inside a bubble, staring at the wallpaper, and finally noticing the fractures that tell us the walls of our world are thinner than we ever dared to imagine. In the end, the golden retina has not just shown us our birth, it has shown us our container. It has revealed that we are not living in a self-contained story, but in a collision in progress. The stars are not where we thought, and time is not moving how we measured, because the very ground beneath us is borrowed energy from a reality we can never visit. We are standing at the boundary, looking at the silence behind the gold, and realizing for the first time that we do not own the room. The door handle is in our reach, but the door is locked by the laws of physics themselves, leaving us to wonder what lies on the other side of the glass, and what it is that the monsters in our nursery are truly shielding us from. You've been watching the astronomers have spotted a galaxy so far away, it raises troubling questions. Don't forget to like and subscribe.